Okay, let's go to page 9. So this is your quiz review. So we're working through pages 9 and 10. So what your quiz will look like, you'll have a portion like this where you have to look at a graph and identify if a limit exists, and if it does, what's the y value? And we know that with limit, we're talking about picking points on either side and seeing if the arrows are in agreement, or finding order pair. Okay. And then another portion of your graph will be taking properties that are listed and sketching a graph that displays those characteristics. And then on the back, you're going to have a series of evaluating limits for different types of functions. Ones that could be a factor array, it could be a conjugate, could be a complex fraction. But we talked about how we never want to assume anything, right? We don't want to jump into all those algebraic steps before we convince ourselves that there's actually a whole. So we always want to do direct substitution, right? Because if I can evaluate a limit initially through direct substitution, if I can get a real number out of it, then there is no hole. The function is continuous. I stop and I just keep moving. I go to the next problem. Right? There's no need to go through those algebraic steps. Likewise, if I were to do a direct substitution, if I got a 10 over 0 or 8 over 0, what does that indicate to me? That there's a what there? Vertical asymptote. And if I get 8 over 0, that means there's a vertical asymptote. What does that tell me about my limits? Yeah, does not exist. And there's no need to go through all your factoring steps if you already know that the limit doesn't exist. Right? So always show me your direct substitution and only do any algebraic work if you're getting a 0 over 0. If you're not getting a 0 over 0, then we don't do any of those steps that we have practiced in the past. We either say what the limit is or the limit doesn't exist. All right, so let's start with number 1, part A through H. Try those, and then we can compare our answers. Remember, if you want to decide the limit exists, make sure you pick points on either side of your x value and see if the arrows are in agreement. Now, on the quiz, if you don't show me those arrows, I won't take off points. I'm just, I think drawing those arrows is a good visual way of convincing yourselves of your answer. And if you're able to subcategorize, go ahead and subcategorize. Go ahead and check your answer for number one. Approaching -7, we know the limit doesn't exist because there's a vertical asymptote. However, we can subcategorize because both arrows are headed towards positivity. So DNE parentheses positivity. If you have -7 equals 5, that's just ordered pair. Limit as x approaches -4. If I pick points on either side of -4 and head towards -4, the arrows are obviously not pointing towards each other, not pointing towards the same y value, so limit does not exist. Part E, approaching 1 from both sides. Again, pick points on both sides of 1. The arrows are both headed towards -5, towards the whole, so limit does exist. And H, both sides of 6, is leading me towards a y value of -2. Any questions? Okay. Now, sketching your graph, let me remind us of a couple of things that can be useful as you're creating your graph. If ever a limit exists, go ahead and find out where that order pair is, put a hole where that order pair is, and then just extend slightly from both sides. It's the safest way to do it, I think. And if there's another order pair that later on tells you to fill in that hole, then you fill in that hole. There's no need to erase anything. I think this is the safest way to start off where the limit exists. And also, don't put arrows on either side. Just extend slightly, because if you put arrows, then that could potentially conflict with another part of the graph and fail the vertical line test. So you can just do that. And if you want to extend this a little further later on, you can, but start here if limit exists. And then if the limit is approaching negative or positive infinity, you know that must mean there's a vertical asymptote. But remember, this is a subcategory here. If you see positive or negative infinity, that means you need both. You need to have a consistent movement from both sides towards that same direction. And finally, if limit does not exist, you have a couple of options. You can either make it a vertical asymptote. You can make it a jump discontinuity. Or you can make it an endpoint. It's up to you. So jump discontinuity looks something like this, where if I pick points on both sides of that target, my arrows are not pointing in the same direction. An endpoint, you can just make the graph end and not pick up after that. Okay, what you don't want to do is you don't want to make a graph look like this, right? If you have a hole, that's not good enough because the limit does exist if you do this, because if I pick points on either side of that graph, both sides is headed towards the same y value. So this would not fulfill the condition of a limit doesn't exist. This one, limit does exist. Okay, so spend a minute, sketch your graph. I'll put my version of the graph up on the board, but then yours will probably look a little different than mine. So I'll circle the room and glance at your graph and see how it looks. Or if you have any questions, I can answer them. template. Let's see. Does that make you part? That's so you see how this build vertical line goes to first. So I mean, or maybe you erase this part and just have that part there. Just make sure that everything. Also make it the other ones. The homework is going to come from the exercise pages. So you're able to so page 9 and 102. Just pick up the problems. If you practice, see practice, you can do it directly at the exercise problem too. It's an issue. Good. Start with it. Yeah. It just means that at any problem, you just got to make sure that there's nothing to find. Okay. There's nothing to go through. That's the point of works. Yeah. No, yeah, this is fine. Yeah, endpoint is fine. Remember with limits, we're talking about arrows here. So you have to pick points on both sides of the arrow. You put both sides of the graph and see if the arrows are headed towards the y value. So if this is getting one point, the limit is never going to be there.
Your age could have modeled this because you can't put it.
Yes, yeah. So this is fine. This is fine. You do a very function fill. You can also make it both sides headed towards the y value. Yeah, options. Yeah, but that looks good. Yeah, then it's like, if by the time you're in agreement, then it's just. It's a question one. Yeah, but.
That's weird. That's yeah.
It's fine. It's this four, you can also make it a third factor. You can also make it connected to one side and not be. That's yeah. Yes. It's piecewise function, so we can have a point defined way faster. So as long as nothing failed or point fits with it. Yeah. Okay, your first page looks good. Go ahead and go to page 10. Right, again, even if you feel like you know where the problem is headed, don't skip the first step. Always do direct substitution first. You're only going to do all those algebraic factoring, conjugate, complex fraction, common denominator steps if you get a 0 over 0. If you don't get a 0 over 0, it's either because it's already the limit or the limit doesn't exist. So number 3, direct substitution gave us 0 over 0. That convinces us that there's a hole. We know there's a complex fraction problem. We have to resolve that, set that individual fractions above. Find a way to merge it. The way we can merge it is doing common denominator, combining it into one fraction, cleaning that up, and then we can put it back into the problem and bring the x up to the top, cancel it out, and revalue it. Any questions about the cleanup process up to where the fractions combine? Number 4, direct substitution tells us that there's a vertical asymptote. Nothing more to do, right? We don't want to go into all those factoring steps if there's no hole for us to find. Limit doesn't exist. Number 5, 0 over 0. We know there's a whole radicals involved, so multiply numerator and denominator by the conjugate. Careful that protect what comes after a minus sign with a set of parentheses. As a reminder, we got to distribute through. And then when you clean up your numerator, sometimes the numerator and denominator are not quite a perfect fit yet. In this case, it is. But just be careful that if something's not a fit, you may have to factor something out to get it to be a fit before you can match the factors and cancel out. So sometimes it's a sign that's off. Sometimes it's another GCF you got to factor out. But the big hint is that if you get a 0 over 0, you know there's a hole. And also the hint is that there's an x minus 2 sitting below. This is causing a 0, so you know ultimately there is going to be an x minus 2 hiding somewhere, right? Sometimes sometimes you have to go a little, do a little more work to get that factor to show up, but you know there's going to be a guaranteed x minus 2 above, especially if you already know there's a hole. So you already know where you're looking for, you just have to kind of work your way to that point. Okay, so number 6 is a reminder. If I have a 0 over a non-zero, that is a real number. That is 0. So let's make sure we understand all the different variations of 0. 0 over a non-zero is 0. A non-zero over 0 is vertical asymptote, and then 0 over 0 is a hole. 7, direct substitution gives us 0/0. Binomial factoring, but GCF needs to come out first, so I factor the 2 out. Then 2x squared minus 11x plus 5, you can go through star method or grouping method, whichever method you factor with. Eventually, what you do to get that x minus 5 to show up, x minus 5 and 2x minus 1. Take out your common factors. You know the whole has been removed. Reevaluate your limits. We're expecting a real number now. Questions? It's kind of arbitrary. Would you do that? Because it's a piecewise function. Normally, no function can ever do this. But give all these different families of functions that are in place on the same level. So the vertical line has any given column function. For number 8, just be careful that when you have √3 plus √3, that doesn't become 3. We're not multiplying, we're adding it. So we're adding like terms here. 1√3 plus 1√3 is 2√3. And also in this course, you don't have to rationalize your answer. So leaving a radical in the denominator is fine. AP exam won't come, they won't take off any points for that. I think the only time you have to worry about rationalizing a denominator is if the multiple choice of your AP exam problem is showing a rationalized version. Then you have to maybe rationalize it just so you can find the match in the answer choice. That's the only time you have to rationalize it, just being able to do it so you can match the answer. But if it's true response, radical in the denominator is never going to be an issue. Number 9 and 10, they both look like complex fraction problems, but we always want to take our first step, convince ourselves that there's actually a hole before we jump into all of our cleanup steps, common denominator steps. let me walk through number 10 here. We know we're getting that 0 over 0 to show up. We know there's a hole. And we know we have to spend time to clean up that numerator portion. So 3 over x minus 3 is same thing as 3 over x minus 3 over 1. Our common denominator is x. We balance each fraction. We get 3 minus 3x over x, all over x minus 1. We know that at the beginning of the problem, we already know that this x minus 1 is obviously what's causing the hole. And so there's an x minus 1 that's hiding in the numerator portion as well. We know that dividing by x minus 1 is the same thing as multiplying by the reciprocal form. But this still feels a little mismatched, right? We know that we're trying to get an x minus 1 to go away. There must be an x minus 1 hiding here, but maybe we got to do a little bit more factoring to get that to show up. So if I factor 3 out, that would be 3 parentheses 1 minus x. But even at this stage, the sign is still a little bit off. You see that 1 minus x is not the same thing as x minus 1. So what if I factor a negative 3 out? If I factor a negative 3 out, then I'm left with negative 1 plus x. Now I'm in a better position to actually cancel out. Because I know that x minus negative 1 plus x, same thing as x minus 1. The order is different, but the signs are matching. So now we can factor out. Or sorry, now we can remove the factor. So the only thing left over is negative 3 over x. We reevaluate our limits. We get negative 3 over 1. The hole has been removed. So negative 3. So a lot of times, think of your, especially once you know that there's a hole, think of your denominator as your anchor, because you know that ultimately you know what you're looking for in the numerator. And if you haven't found it yet, sometimes it just requires a little bit of factoring and cleanup to get those to match, because you know what you're trying to show, you know what you want to show up. So just have to keep working until you get there. All right, any questions? So this is what your quiz will look like. On the quiz, there won't be as many of these problems on the back, but I wanted to go through all the different variations so that you feel comfortable. So tomorrow is your quiz. I'll have a help session, morning session at 7:30. I'll send you guys a link to Remind if you want to join virtually, but it's also in the classroom. I'm going to go over worksheet 2, and worksheet 2 is up where you can pick up. So when you come get your phones, you can pick up worksheet 2 and either do worksheet 2 tonight as extra practice, or you can wait for me to do it with you tomorrow. It's not homework, it's just extra practice if you feel like you need additional practice for tomorrow's quiz. All right, come get your phones. The key is attached as well. You can check your answers as you work through. Sorry. Oh. 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 Yes, there will be a space there. Yeah. Guys, one thing on the that's not on your quiz review is you will see a squeeze theorem problem. Okay, so again, squeeze theorem, you're trying to evaluate the middle limits and the outer limits are provided, where information is provided. You do direct substitution for both and then see if the middle is in agreement with the outer ones. Or sorry, see if the outer ones are in agreement. If they are, the limit exists. If the outer limits are different, then the limit does not exist. And yeah, so there will be a squeeze theorem problem. Well, I'll go over one in the help session. I did not include it in the review sheet though. Yeah.